Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Imagine this. You're seated in a control room surrounded by glowing monitors as the James Webb Space Telescope quietly beams down data from over 1 million miles away. You've spent weeks combing through the JADES survey, an ambitious project meant to peel back the layers of cosmic time, and suddenly you see something odd. A dip in a light spectrum, a redshift that seems impossibly high. You check again, then again, and finally you realize this isn't a mistake. It's real. You've just found a galaxy so ancient, so luminous and so massive that it defies everything we thought we knew about the early universe. The galaxy's official designation is JADES G S Z 13-0. It may not sound poetic, but this string of characters marks one of the most extraordinary discoveries in modern astronomy. This galaxy's light began its journey more than 13 billion years ago, just 325 million years after the Big Bang. To put that into perspective, if the entire lifespan of the universe were compressed into a single 24-hour day, this galaxy would have appeared less than 23 minutes after midnight. And yet, even at this impossibly early hour, JADES G S Z 13-0 was already blazing with youthful brilliance. Now, this wasn't supposed to be possible. According to the Standard Model of Cosmology, the LCDM model, short for lambda cold. Dark matter. The early universe was a chaotic fog of hot plasma. After the Big Bang, it took around 380,000 years for things to cool down enough for atoms to form. That era, called recombination, gave us the cosmic microwave background. What followed was a long, dark stretch known as the Cosmic Dark Ages. The first stars and galaxies weren't expected to ignite until perhaps 400 million to 600 million years after the Big Bang. Even then, they were presumed to be small, chaotic, and disorganized. Primitive, building blocks slowly merging to form larger structures over hundreds of millions of years. And yet here we are, staring at JADES G S Z 13-0, a galaxy that formed less than 400 million years into cosmic history and already exhibits characteristics of a much more evolved system. The JWST's NIR-CAM and NIR-SPEC instruments, short for Near-Infrared Camera and Near-Infrared Spectrograph, revealed not only the galaxy's extreme redshift, estimated at 13.2, but also spectral fingerprints of ionized oxygen indicating ongoing star formation and chemical enrichment. That's important because oxygen doesn't come from the Big Bang. It comes from stars that live and die, enriching their surroundings with heavier elements. In JADES G S Z 13-0, the presence of these metals implies that multiple generations of stars had already lived and died, within just a few 100 million years of time existing. It's not just old, it's fast, and that raises a fundamental question. How? How could gas collapse, fragment, ignite, and recycle fast enough to produce this level of complexity so soon? Where did the raw materials come from? Was dark matter denser or distributed differently than we thought? Or is there something we're fundamentally missing about how physics worked at the dawn of time? To understand just how profound this is, think about galaxy formation like a skyscraper under construction. According to traditional theory, the first galaxies were scaffolding, temporary, unrefined, slowly pieced together with crude tools. JADES G S Z 13-0 is a fully operating penthouse apartment before we've even laid the foundation. This isn't just an interesting case study, it's a paradigm threat. When the James Webb Space Telescope launched in December of 2021, many expected it to push boundaries, but few anticipated this level of disruption. Designed to look farther into space, and therefore further back in time than any telescope before it, JWST was equipped to explore the reionization epoch, the moment when starlight began reionizing, the neutral hydrogen that filled the universe. Scientists hoped to spot a few primitive galaxies beginning to form. Instead, they found this. The galaxy's ultraviolet luminosity suggests a prodigious star formation rate, possibly exceeding 20 solar masses per year. That's comparable to the Milky Way today, yet it's happening when the universe was still in its cosmic infancy. And let's remember, the Milky Way is over 13 billion years old. JADES G S Z 13 was already pumping out stars like a pro when galaxies were barely out of the cosmic womb. And that's not all. Its mass inferred through deep photometric analysis indicates it had already assembled several 100 million solar masses worth of stars. That's massive. Not as enormous as galaxies we see today, but certainly not what you'd expect from a first-generation galaxy. This single object is now forcing astrophysicists to revisit long-standing assumptions: the efficiency of gas cooling, the role of turbulence in early star-forming regions, and whether dark matter halos merged faster than our simulations predicted. Some even speculate that new physics could be at play, perhaps interactions beyond the standard model, or exotic forms of dark energy that we haven't yet accounted for. It's not hyperbole to say this is one of the most important galaxies ever found. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. The excitement among astronomers is palpable. Teams across the globe are now combing through JWST data, hoping to find more ancient beacons like JADES G S Z 13. Because if there's one, there may be hundreds or thousands. Galaxies that formed and matured long before our models said they should. This isn't just a new discovery. It's a cosmic whisper from the universe itself, a whisper that says, you've only just begun to understand. The discovery of JADES G S Z 13 is like finding a futuristic skyscraper in the ruins of ancient Earth, completely out of place, shockingly advanced, and brimming with implications. But this discovery didn't just appear out of nowhere. It was the product of decades of technological evolution, scientific ambition, and a deep desire to answer one of the most haunting questions in astronomy. How did the first galaxies really form? To grasp the full impact of JADES G S Z 13, we need to travel back, not in space but in time, to the origin of our quest. For centuries we saw the night sky as static. The stars were thought to be eternal, the universe unchanging. Then came the revelations of Edwin Hubble in the 1920s. Hubble discovered that galaxies are not only far outside our own Milky Way, they're racing away from us, with more distant galaxies receding faster. This was our first clue that the universe is expanding. Fast forward to the late 20th century, and the Hubble Space Telescope, launched in 1990, transformed our understanding of deep space. One of its most iconic achievements was the Hubble Ultra Deep Field, revealing over 10,000 galaxies in what appeared to be an empty patch of sky no bigger than a grain of sand held at arm's length. That image alone rewrote the cosmic narrative. But even Hubble had limits. Its primary cameras were tuned to ultraviolet and visible light, making it blind to the far infrared glow of the earliest galaxies, which have been redshifted beyond its reach by the stretching fabric of the universe. That's where the James Webb Space Telescope enters the story, not just as a successor but as a cosmic time machine. Its powerful gold-plated mirrors and cold-operating infrared sensors were designed specifically to detect the faintest light from the earliest stars. But let's be clear, Webb was not expected to break the universe. It was expected to illuminate it, to confirm the timeline we thought we already understood. Instead, it shattered our assumptions. Let's break this down. The light from JADES G S Z 13 was redshifted to a degree that placed it just 325 million years after the Big Bang. That redshift, around 13.2, is more than just a number. It tells us how much the universe has expanded since that light was emitted. It tells us how long that light has been traveling, and it tells us that this galaxy existed far earlier than the models allowed. But redshift isn't the only story. What's truly astonishing is what that light revealed. When Webb's NIR-SPEC instrument dissected the light spectrum from JADES G S Z 13, it didn't just show a young galaxy, it showed one already teeming with metal-enriched gas. That's astrophysical code for this galaxy had already gone through star cycles, Massive stars had formed, lived and died in spectacular supernovae, seeding the interstellar medium with elements like carbon, nitrogen and oxygen. To astronomers, that's like finding a fossilized city where only primitive huts should exist. Metals in cosmology are any elements heavier than hydrogen and helium, and they are forged in the hearts of stars. The more metals a galaxy has, the more mature it is. So how could such a galaxy have so many metals so early? One possibility is that star formation in the early universe was far more efficient than we imagined. Instead of slowly condensing from turbulent gas clouds, perhaps the first stars were born in enormous bursts, dozens or hundreds of them igniting almost simultaneously. These population 3 stars, as theorized, would have been massive, perhaps hundreds of times more massive than our Sun, and they would have lived brief, brilliant lives before exploding. The debris from their deaths could have quickly seeded the next generation of stars, allowing a galaxy like JADES G S Z 13-0 to evolve at lightning speed. But here's the twist. We haven't definitively observed population 3 stars yet. They're like ghosts, predicted by theory, hinted at by data, but never clearly seen. Could JADES G S Z 13-0 be the product of such stars? Or is it evidence that something even more radical happened in the early universe? This is where things get speculative and fascinating. Some cosmologists have proposed that dark matter, an invisible, mysterious substance that makes up 85% of the universe's mass, may have played a more aggressive role in early structure formation. If dark matter clumped more efficiently in the early universe, it could have created deeper gravitational wells that sucked in gas more rapidly, igniting starbursts earlier than expected. Others suggest that we may need to rethink the timeline of cosmic inflation, the rapid expansion of the universe fractions of a second after the Big Bang. If inflation ended even slightly differently than predicted, it could have led to earlier pockets of density, accelerating the birth of the first galaxies. But perhaps the most tantalizing idea is that we are seeing the fingerprints of new physics. Some theorists have speculated about early dark energy, a force that briefly acted in the young universe, altering the expansion rate just enough to let structure form faster. It's a bold idea, one that challenges the very scaffolding of our cosmic model, but it's not without merit. As our instruments become more sensitive and our surveys more detailed, we may find that the early universe was not just surprising, but fundamentally different, and it all circles back to one galaxy. One impossibly ancient, luminous, structured galaxy that shouldn't exist, and yet defiantly does. JADES G S Z 13-0 isn't just an object, it's a message from the early cosmos that says, your models are beautiful, but they're incomplete, and now a race has begun. A race not just to find more galaxies like it, but to understand what their existence means. Could this be the tip of a cosmic iceberg? Could our timeline of cosmic evolution be off by hundreds of millions of years? Or is there something stranger at play, something we haven't even begun to fathom? The stars may be ancient, but their whispers are only now being heard. When the light from JADES G S Z 13-0 first reached the sensors of the James Webb Space Telescope, it didn't scream revolution. At first it whispered, a faint red smudge on a deep sky mosaic, nestled among other specks that represented galaxies, stars, and dust from across the cosmos. But as scientists began analyzing the data in painstaking detail, that whisper grew into a thunderclap that echoed through observatories, university halls, and cosmology forums across the world. You see, when something doesn't fit into the model, especially a model as precise and long-standing as lambda cold dark matter, the standard framework of cosmology, it forces a reckoning. And in this case, the reckoning was not quiet. Let's pause and look at what that model says. Lambda cold dark matter, or lambda CDM, has been our guiding star for decades. It tells us that the universe began with the Big Bang around 13.8 billion years ago. It expanded rapidly through cosmic inflation, then cooled, allowing hydrogen and helium atoms to form. Around 400,000 years later, photons were freed, what we now see as the cosmic microwave background. And only much later, about several 100 million years in, did the first stars begin to shine, kicking off the era known as cosmic dawn. According to this framework, galaxies, like JADES G S Z 13-0, complex, metal-rich, and massive, shouldn't exist less than 400 million years after the Big Bang. That timeline simply doesn't give the universe enough time to assemble such a structure through known physics. So what happens when reality outpaces theory? That's when scientists go hunting for answers, or cracks. Almost immediately, theorists began revisiting their simulations. Some argued that cosmic variance, the idea that certain regions of the universe might evolve faster than others, could explain it. Maybe JADES G S Z 13-0 is a statistical outlier, a rare fluke from a particularly dense patch of early space where gravity pulled gas into stars at extraordinary speed. But even that explanation strained credibility. Other early galaxies, discovered by JWST such as Sears 9 and Glasses 13, showed similar traits, massive, luminous, and alarmingly mature for their age. It wasn't a one-off, it was a pattern. Others suggested we may have misunderstood redshift itself. After all, redshift is how we estimate distance and age in the universe. Could we have misread the spectral signature? Could the light from JADES G S Z 13-0 be contaminated or mimicked by closer objects or gravitational lensing effects? That was a fair question. But the data from JWST's NIR spec instrument, which provides spectroscopic confirmation, not just imaging, left little room for doubt. The redshift was real, the galaxy was ancient, and the implications were massive. Then came a bolder idea. What if the universe itself is older than we think? This radical proposal emerged from the fringes but quickly gained traction among some mainstream theorists. If the expansion rate of the universe, encoded in what's called the Hubble constant, is different than previously believed, then our age estimates for distant galaxies could be off. But this isn't just idle speculation. It taps into a real problem in cosmology known as the Hubble tension. Put simply, when we measure the expansion rate using nearby galaxies, we get one number. When we measure it using the cosmic microwave background from the early universe, we get a different number. Both can't be right unless something deeper is at play. Maybe that something is a hidden force, an unknown particle, or an error in how we interpret the fabric of space-time itself. And here's where the story veers from scientific into almost philosophical. If JADES G S Z 13-0 is real and all evidence says it is, then we may be standing at the edge of a paradigm shift, a moment akin to Copernicus proposing that Earth isn't the center of the universe, or Einstein upending Newton's gravity with the concept of space-time curvature. In other words, we may not just need to adjust the model, we may need a new one entirely. One alternative gaining attention is early dark energy, a brief, intense burst of dark energy in the young universe that could have sped up early galaxy formation before fading. This idea fits the data, but it would radically change our understanding of the forces at play in the cosmos. Another proposal involves modifying gravity itself, perhaps through scalar fields or alternate metrics that only manifest in the dense, high-energy conditions of the early cosmos. And then, of course, there's the wild card, the multiverse. Some string theorists have long proposed that our universe is just one of many, a bubble in a cosmic foam. If that's true, then perhaps our universe has properties that are unusual, but not impossible in the grand scheme of possibilities. Maybe early galaxies like JADES G S Z 13-0 are normal in some bubbles and rare in others. That's not an answer, it's a cosmic shrug, but it does push us to think beyond traditional boundaries. What's clear is that this single galaxy has opened a Pandora's box, not of chaos, but of questions. What came before cosmic dawn? Were there different physical laws? Are our telescopes peeking into regions of space where the rules have subtly changed? These aren't just esoteric debates for ivory tower scientists. They matter because they redefine everything we thought we knew about our origins. They ripple outward, touching how we interpret the universe's structure, how we understand time itself, and ultimately, where we fit into the grand design. It's no longer just about one galaxy, it's about the story of all galaxies. It's about the strange silence before the first light, and what secrets may still be hiding in that. Ancient darkness. And if JADES G S Z 13.0 is the beginning of a new chapter, then we're only on the first page. Now, as we journey deeper into the heart of the cosmic mystery surrounding JADES G S Z 13.0, we start to realize just how much the discovery of this galaxy impacts not only the field of cosmology, but also our very understanding of existence itself. The implications reach far beyond simple galaxy formation. They challenge the most fundamental aspects of physics, pushing us toward questions that have lingered at the edges of scientific inquiry for centuries. As the story of this galaxy unfolds, we're forced to confront some of the most profound questions humanity has ever asked. How did everything we know come to be? And more tantalizingly, are we alone in the universe? To understand the weight of these questions, let's first examine the role galaxies like JADES G S Z 13.0 play in our quest to comprehend the cosmos. Historically, we've thought of galaxies as self-contained systems, bodies of stars, gas, dust, and dark matter that form over billions of years. But the closer we look, the more we realize that galaxies are not just passive observers in the vastness of space. They're active players in the cosmic drama, shaping the universe in ways we're only beginning to understand. Think about the moment you first see a distant galaxy through a telescope, a faint speck of light that seems insignificant in the grand scale of the universe. Now imagine that speck isn't just a galaxy. It's a cosmic treasure chest, holding within it the answers to some of the universe's greatest mysteries. That's what JADES G S Z 13.0 represents. Not just a galaxy, but a time machine, a snapshot of the universe at a time when it was still young and full of untapped potential. But here's the thing. As much as we've learned about galaxies, we still don't fully understand how they form, evolve, and interact. For decades, the prevailing theory has been that galaxies form through the slow, steady accumulation of gas and dust over millions of years, gradually coalescing into the bright, complex structures we see today. But JADES G S Z 13.0 is different. It's a galaxy that defies all expectations, and it's forcing us to reconsider how galaxies might form in the first place. When scientists first observed the galaxy's remarkable size and complexity, they were left scratching their heads. How could this galaxy have formed so quickly after the Big Bang? Was it simply a statistical fluke, an anomaly in the data? Or does JADES G S Z 13.0 point to a new way of thinking about cosmic evolution? As researchers dug deeper, they began to realize something even more surprising. JADES G S Z 13.0 might not just be a unique galaxy, but a glimpse into a much larger, previously unseen phenomenon. Some scientists now believe that the galaxy could be a relic from a period in the early universe when galaxies formed much more rapidly than we previously thought. It could be a window into a lost era of cosmic history, an era when the universe was more chaotic, more dynamic, and far more unpredictable than we ever imagined. In many ways, the discovery of JADES G S Z 13.0 forces us to confront the limits of our knowledge about cosmic evolution. For years, we've been operating under the assumption that the universe followed a predictable linear progression, a steady march from the Big Bang to the present day. But the more we learn about galaxies like JADES G S Z 13.0, the more we realize that the history of the universe is far messier and more complex than we ever thought. This new understanding has profound implications not only for our view of the cosmos, but for the nature of time itself. We've always thought of the past as a linear progression, a series of events that happened in a specific order. But if galaxies like JADES G S Z 13.0 formed much earlier than we expected, it raises the possibility that the timeline of the universe is far more flexible than we've been led to believe. What does this mean for our understanding of time? Could there be regions of the universe where time operates differently, where the laws of physics behave in ways we don't yet understand? Could JADES G S Z 13.0 be a clue to a deeper, hidden structure of the cosmos, one that is governed by principles we haven't even begun to grasp? And that's where things get really interesting, Because if we're truly on the verge of uncovering a new, more complex timeline for the universe, it could have profound implications for our search for life beyond Earth. After all, if galaxies like JADES G S Z can form in ways we didn't expect, could there be other civilizations out there that developed in entirely different ways than we've imagined? Could there be alien life that has evolved in environments so alien to us they seem impossible, yet they exist, waiting to be discovered? This question isn't just idle speculation. It's at the heart of the Fermi Paradox, the age-old mystery of why in a universe so vast we've yet to find definitive evidence of extraterrestrial life. For decades, scientists have wondered why, with all the stars and planets out there, we haven't detected signals from an advanced civilization. Maybe, just maybe, the answer is that we're looking for the wrong signs, in the wrong places, or at the wrong times. What if civilizations formed much earlier than we thought, during a time when the universe was still young and chaotic? What if the rise of intelligent life on Earth wasn't the first time the universe gave birth to advanced beings? The discovery of JADES G S Z, a galaxy that challenges everything we thought we knew about cosmic evolution, opens up the possibility that we may not be the first or the only intelligent life forms in the universe. As these questions hang in the air, we're left with one simple yet profound realization. The universe is far more mysterious than we ever imagined. And galaxies like JADES G S Z are not just cosmic curiosities. They're the keys to unlocking secrets that could change everything we know about ourselves, our place in the universe, and the possibility of life beyond Earth. As we reach the final chapter of our journey into the heart of cosmic discovery, we are left not just with more questions, but with the awe-inspiring realization that the universe is far more complex, dynamic, and interconnected than we could ever have imagined. The discovery of JADES G S Z, this mysterious galaxy that has challenged everything we thought we knew about the formation and evolution of galaxies, is more than just a breakthrough in cosmology. It's an invitation to reconsider everything. Now that we've journeyed deep into the implications of this discovery, one thing becomes abundantly clear. JADES G S Z is not just another galaxy in the cosmos. It is the bridge between our past and our future. Its story is one of cosmic rebirth, a galaxy formed at a time when the universe was still finding its shape, its rhythm, and its laws. To fully appreciate this, we must look back at where we started, and then cast our gaze forward, asking what this means for the future of humanity and the search for life beyond our planet. When we first peered into the night sky, we saw distant stars, clouds of gas and dust, and galaxies, but we didn't know what we were looking at. Over time, we developed sophisticated tools, telescopes, space observatories, and instruments that could peer deeper and deeper into the fabric of space. And with each new discovery, we learned more. We discovered galaxies in every shape and form, from the massive, sprawling ellipticals to the delicate spirals that seemed to dance across the cosmic canvas. Yet even as we gained more understanding, there was always the lingering question, what else is out there that we don't yet know? JADES G S Z is the answer to that question, but in an unexpected form. This galaxy, formed at a time just a few 100 million years after the Big Bang, was one of the first to emerge when the universe was still young. It doesn't fit neatly into the models we've spent decades developing. In fact, it shatters them. The existence of this galaxy isn't just a scientific anomaly, it's a paradigm shift. It forces us to rethink our entire understanding of how galaxies are born, grow, and interact with one another. Before the discovery of JADES G S Z, scientists believed that galaxies like it could never exist so early in the universe's history. The conditions needed to create such a complex structure were thought to require billions of years, far longer than the universe had been around at the time this galaxy formed. And yet, here it is, a galaxy that challenges everything. We thought we knew about time, space, and the forces that shape the cosmos. What makes JADES G S Z so important isn't just its size or age. It's the fact that it may hold the key to understanding how galaxies and perhaps even the universe itself, evolved in the first place. It raises the tantalizing possibility that galaxies could form much faster than we ever thought, that the universe itself, in its earliest moments, might have been a much more turbulent and chaotic place, a place where galaxies were born and died in the blink of an eye. It opens the door to a new era in astronomy, one where we may begin to understand the universe not as a slow, steady progression, but as a dynamic, ever-changing dance of creation and destruction. This discovery also invites us to rethink our place in the cosmos. For years, humanity has pondered the question, are we alone? The search for extraterrestrial life has taken us to the farthest reaches of the universe. But even with all our advancements, we've yet to find definitive proof that we are not the only intelligent beings in existence. But with galaxies like JADES G S Z 13-0, we may be closer than ever to finding the answer to that question. If the universe was capable of creating such a massive and complex galaxy in such a short time, what does that say about the possibility of life elsewhere? Could life have evolved on planets orbiting stars in galaxies formed in the early universe, similar to JADES G S Z 13-0? Could there be civilizations out there that have existed for billions of years, hidden in galaxies that are far older and more advanced than our own? This is the essence of the Fermi Paradox, the mystery of why, despite the vastness of the universe, we've yet to detect signs of intelligent life. But now, thanks to discoveries like this one, we are beginning to understand that the search for life may not be as simple as we once thought. What if intelligent life doesn't evolve in the same predictable patterns we expect? What if there are civilizations that are completely different from us? Civilizations that exist in galaxies that are formed in ways we can't even imagine. The discovery of JADES G S Z 13-0 challenges our assumptions about life in the universe, and it suggests that the answer to the Fermi Paradox might be that we're just not looking in the right way or at the right time. As we look forward, we begin to ask even bigger questions. What else is out there waiting to be discovered? What other galaxies are hiding their secrets, waiting for the right tools and minds to unlock them? The discovery of JADES G S Z 13-0 is not the end of the story, it's just the beginning. The universe is vast, and each new discovery is a chapter in an ongoing narrative that is constantly unfolding. So, where do we go from here? How can we build on this discovery to learn even more about the universe and our place in it? It's clear that the future of space exploration holds immense promise. With missions like the James Webb Space Telescope, JWST, which is designed to peer deeper into the universe than ever before, we are entering a new era of discovery. As we continue to push the boundaries of technology and knowledge, we may find answers to questions we haven't even thought to ask yet. But one thing is certain, the discovery of JADES G S Z 13-0 has ignited a fire in the scientific community, and it has set the stage for a new age of exploration and understanding. It reminds us that the universe is still full of mysteries, waiting for us to unlock them. As we move forward, we must keep our minds open and our curiosity burning brightly. And so, as we leave this journey with more questions than answers, we are reminded of the words of the great Carl Sagan. Somewhere, something incredible is waiting to be known. What that incredible thing is, we can't yet say. But one thing is for sure. With discoveries like JADES G S Z 13-0, we are on the verge of learning things that will forever change our understanding of the universe and ourselves. If this journey through the cosmos has inspired you, sparked your curiosity, or made you look up at the night sky with wonder, don't forget to hit that like button, share this video with fellow explorers, and subscribe to Cosmic Whispers. Together, we'll keep unraveling the mysteries of the universe. Let us know your thoughts in the comments. What do you think lies beyond the horizon of our knowledge?